Hi, good day to you all. Welcome to another chemistry class. So, we are treating another topic today, and the topic is empirical and molecular formula. I guess this is SS1 topic, so this is an advantage for you guys writing JAM or the WACS or the upcoming WACS examination. So, it's just like a revision for you. Now, look at this empirical formula. Empirical formula is the simplest formula that can exist within a compound. The constituent of a compound, the simplest form in which you can express them is empirical formula. If you have H2SO4, the ratio of H to S to O can be expressed in a simple formula H2SO4, and that is the empirical formula. But the molecular formula is an advanced formula. Is a formula that expresses the correct ratio of the elements present in that compound. Now, you might be wondering which one is this empirical, which one is this molecular. From the word molecule, that one has to do with the molecular constituent. Because if you have H2SO4 as your empirical formula, you can easily make another derivative as H, I'm just assuming we don't have any formula like H4. H4, S2, O8. Another derivative. By the time you divide through with the empirical formula, the molecular formula, if you divide it maybe by 2 or a particular number, you eventually get your simplest form, which is the empirical formula. Now let's look at this question for proper understanding. A compound was found by analysis to contain 65.45 of carbon, 9.09 of hydrogen, and 25 plus 45 of nitrogen. Now we are told to calculate the empirical formula. Mind you, all these are the mass numbers of the constituent of that compound. Now let's make it this way. We have carbon, that's the constituent, carbon, hydrogen, and nitrogen. Good. Carbon, hydrogen, and nitrogen. Now, we want to write out the empirical formula first. Let's go with empirical formula. Now, we were given the percentage. Carbon is 65.45. Hydrogen is 9.09, while the nitrogen constituent is 25 plus 45. The first step for you to get the empirical formula of a particular compound is dividing it through by their mass numbers. Now, what's the mass number of carbon? You divide this by 12, divide this by 1, and you divide this by 14. So let's go. 40. We have 65.45. 65.45. What do we have? 5.45. Let's have 5.45. Is that taken? Now let's go. That one is 9.09. Well, this one, if you divide it, 1.82. Always leave in 2 decimal places. Leave in what? 2 decimal places. So now, having gotten that, what next? You divide by the smallest ratio. Looking at this, we have 5.45, 9.09, 1.82. Divide by the smallest ratio. What's the smallest ratio here? 1.82. So what do we have if you divide 5.45? We have 3. 3, 5, and this is automatically 1. So now, let's deduce our empirical formula. Very simple. How many atoms of carbon? 3. How many atoms of hydrogen? 5. And how many atoms of nitrogen? N. Simple as that. Simple as ABC. No need to write the 1 under here. So this is the simplest form, and that is the empirical formula. Is that taken? Okay, I will have to rub this off for this second part. So now let's look at this. A sample of organic compound contains 0.624 gram of carbon, 0.065 gram of hydrogen, and 0.364 of gram of nitrogen and 0.208 of oxygen. So you'll be wondering, this one was given to us as percentage, while this one is given to us in gram. It's still the same thing. The only thing you just have to do is make sure you know the mass numbers. Once the mass numbers are given, then you can easily divide through. Now, this is what I'm talking about. For the second part, we have carbon, we have hydrogen, we have nitrogen, and we have oxygen. I don't know why this thing is so stiff. It's not adjusted. Okay, I think it's better that way. Okay, so what is our carbon? 0.64, 624, hydrogen 0.065, nitrogen 0.364, and our oxygen 0.208. Now, what is the mass number of carbon? 12. Hydrogen 1, nitrogen 14, and oxygen is 16. So let's divide through. What do we have for the first one? 2.052. 0.052. Hydrogen 0.065. Nitrogen 0.3, 0.026, 0.026, while oxygen divided by 16, 0.013, 0.013. Now let's look at everything. The smallest ratio is 0.013. That is the smallest ratio. So we are going to divide through by the smallest ratio. So this one divided by 0.013, 0.013, 0.013, 0.013. At least I know this one is 1, this one is 2. So now let's look for this one. This one should be 5, yes? While this one should be 4. Good. Now, this is the what? The reacting ratios. 4:5:2:1. So let us write out the empirical formula out first. Let us write out the empirical formula. And how do we write out? The empirical formula is like this. Carbon is 4, C4. Hydrogen is 5, H5. N is 1, N1. And our N is 2, and our O is 1. So let's leave it like this. Yes. I haven't gotten this one as our empirical formula because that's the simplest form in which that compound exists. Now let's go ahead with the molecular formula. So the question says, if the relative molecular mass of that compound is this, what will now be its molecular formula? This is how you find molecular formula. The B part, you write the empirical formula out. N2O into bracket N equals to this molecular mass given to you, 194. Can you see it? Or I should adjust the lens? Okay. So now look at it well. We have equated it like this. But we need to find the molar mass of this compound. Carbon is 12, right? So that will be 12 times 4 plus 1 times 5 plus 14 times 2 plus 16. Everything N equals to 194. 12 times 4, 48, plus 5 plus 28 plus 16. 53, 81, 97. equals 194. So this is 97n equals 194. If 97n is this, so what will be our n? 194 divided by 97, and that will give us 2. So we now go back, because it is molecular formula we are looking for. We now go back here and write out the real molecular formula. Haven't gotten our n as 2. The real molecular formula goes thus. We have C4H5N2O, empirical formula, times 2 to get our molecular formula. So molecular formula will now be 4 times 2, 8, C8, 5 times 2, 10, H10, 2 times 2, 4, N4, 1 times 2, 2, O2. Yeah, that is our molecular formula. Gaskia. All right, we'll see you next class. Ciao.